Hello, good morning, good afternoon, or good evening. Wherever you are on the planet, welcome to Earth911's Sustainability in Your Ear. This is the podcast conversation about accelerating the transition to a sustainable carbon neutral society, and I'm your host, Mitch Ratcliffe. Thanks for joining the conversation today. Honeywell International is one of the world's largest companies, ranking 115th in the Fortune 500 and operating in 70 countries around the world. With lines of business in aerospace, building technology, workplace safety, and digital technology, Honeywell is applying its expertise to reduce its environmental impact. Since 2018, Honeywell has reduced CO2 emissions by 18%, progress towards its goal of being carbon neutral by 2035. An important aspect of Honeywell's progress is its focus on reducing its operational carbon intensity. That's the amount of CO2 it generates per $1 million of revenue. That fell from 60.5 million tons of CO2 per $1 million of revenue in 2018 to just 49.5 million tons in 2022. Clearly, there's a lot of progress that needs to be made, but that is a step forward. Our guest today played a big part in that progress. Dr. Gavin Towler is Chief Sustainability Officer at Honeywell. He brings more than 30 years of experience in the chemicals and fuels industry to the conversation today, and he's helped Honeywell reduce its emissions associated with its refrigerants and electric vehicle solutions while engaging in a wider industry conversation to encourage environmental progress. Some of the projects that Honeywell currently pursues includes emissions management systems for oil and gas facilities that monitor and measure those emissions, as well as recover flare gas that traditionally was burned as waste. The company also launched battery energy storage systems to back up electric grids and is a leading producer of blue hydrogen, which is made from natural gas, at a facility that scrubs 98% of the CO2 produced by the process. Clearly, there's a lot of innovation going on, and Dr. Towler is in the thick of it, so it'll be an interesting conversation. You can learn more about Honeywell at honeywell.com, where the company's sustainability report is featured on the homepage. Now let's get to the conversation, but first, a quick commercial. Welcome to the show, Gavin. How are you doing today?
Very good, thanks. Nice to talk with you.
Well, thank you for coming in and talking with us. Honeywell, as a very big company, is in an interesting and kind of unique position to address a question that drives many businesses to resist environmental progress, and that is, does being sustainable mean you have to be less profitable? What's your take on that question?
Well, for Honeywell, 60% of our revenue comes from what we call our ESG-oriented portfolio. So that's sustainability, safety, resilience products. So clearly for us, profitability and doing things for the environment and for safety and sustainability are very, very highly correlated, right? But because we sell these safety, resilience, and environmental systems to others, we can't do that business if all of our customers just viewed it as a cost that they had to avoid.
Sure.
So we've had to create technologies or find the spaces where those technologies can create value for the customer as well as making them safer, right? I mean, obviously, everybody does want to be safer and more resilient, and everybody wants to lower their impact on the climate, but they want to do it in a way that they also get to make money.
Well, now you do a lot of business with, for instance, with the oil and gas industry. Are they coming to you looking for ways to decarbonize, or do you find that you still have to sell into that industry?
Oh, they're very much coming looking for solutions. And I'll give a couple of good examples here. One is, something that we were stressing a lot at the COP meeting last year, methane emissions. Mm-hmm. Well, okay, methane emissions. If you're in the business of selling oil and gas, you probably don't want to be putting methane in the air, because the alternative would be you find it and you sell it and you make money. Problem is, it's just hard to find methane, right? Methane's not visible, and where's it leaking from? Well, you don't really know. So we put a lot of effort into developing a suite of technologies for finding methane emissions and detecting them using a combination of static sensors and cameras that actually let you see methane by basically looking in the infrared part of the spectrum, so that people who are running facilities like gas distribution networks or oil refineries or things can actually find where the methane emissions are and then deal with them. Now, that has a huge impact on global warming, but aside from the impact on global warming, it just every cubic foot of methane that you don't accidentally vent or accidentally release into the atmosphere, you can sell. So it's a great payback. It's one of the, when you rack those things that, you know, when you line up all the different options on your abatement curve, it's one of the things that's right over on the left with the best possible paybacks. I'll give another example from the oil and gas industry, and that's sustainable aviation fuel. Now, you know, different parts of the world are going at that with carrots and sticks, right? In the US, we have incentives. In Europe, they have a mandate. It doesn't really matter. The rules that are being set by CORSIA, by the aerospace industry, by the aviation industry, are that they need to get their carbon footprint down. They know this. Their customers are saying, we want to fly, but we want to fly with lower carbon footprint. Okay. So everywhere in the world, people are taking different approaches. The end result is that the refiners now have an opportunity to either switch over their assets and be the sustainable aviation fuel producer, or watch somebody else come in, take their market away, and somebody who wasn't an oil company, wasn't in the business of refining, will build that plant to make the sustainable aviation fuel and will enter the business and take the most lucrative part of that business. Well, that's why companies like BP and Shell and Exxon are coming to us and saying, okay, what technology do you have? And making their decisions, then do they go with our technology or our competitors, and figure out what their path is to be able to produce that sustainable aviation fuel. Because the likes of BP, Exxon, Shell, they're not going to sit back and just watch while the industry gets taken over by new companies coming in.
Now, as I was preparing for this interview, I read a lot about your background, and you're an advocate of using existing technology to solve the climate crisis. And the question came up over and over as I read, do we have all the tools we need? And where are the gaps?
Yeah, there are. So first of all, I'm an advocate of not waiting to solve the climate crisis. Right? We know more or less, we can more or less technically frame out the answers of what a net zero future looks like. So we know the things that we need to do. There are, when you look in terms of you know, carbon abatement curves, whether you're looking at a building, a country, an oil refinery, a company, a corporation, whatever it is, they all kind of look the same. They've got some options where you've got to pay back now. They've got some things that are more expensive. The stuff where there's a payback now, you should be moving on it now. Don't get me wrong, all technology can always be improved. So I absolutely support people continuing to work on making everything better. And all the technologies will get better, and that means that they will get cheaper. And that means that in the future, it will be possible to do this at somewhat lower cost. None of that is a reason to say, okay, well, let's just wait another 10 years and have 10 more years of global warming and see how bad things get before we decide to take action. So we should be taking action with the technologies that are ready now, and we should be improving them and figuring out what we can do to make them better in the future. And most of the things that we do, actually, you know, even if you deploy the technology now, you'll be able to upgrade it later. So, you know, for example, that sustainable aviation fuel, if you build a plant now, yes, 5 years from now, we'll have better catalysts. 10 years from now, we'll probably have better ideas on energy efficiency. We may have more experience with running it using heat pumps and running it fully on renewable electricity. None of that should stop you from building the plant now and then getting as much benefit as you can in the meantime. And sure, 10 years from now, you'll be able to upgrade it to be better. But a lot of these technologies can be layered in. So you can still take the benefit of the future advantages. But that, again, is not a reason to say, okay, well, let's wait, let's leave it another decade before we take action.
Are there technologies that are available now that you feel that industry is underinvesting in? SAF, sustainable aviation fuel, being an example, only about, well, less than 1% of all aviation fuel is sustainable at this point. Are those fuel companies missing an opportunity to get in early and really grab part of that market share?
The sustainable aviation fuel market is growing pretty fast. You know, we had licensed, I think, 3 plants between 2000. You know, we launched the technology in like 2010, and we licensed 3 plants by 2019. We've now licensed 50. So a lot of people are signing up. Of course, it takes time to get the permits to get a plant actually built and to bring it into production. So it'll still be a while before we see that scaling up to actually meet a big part of the supply. I would say the areas where it's not really where there's lack of investment. There are areas where we're making it more difficult than it needs to be, right? So, for example,
How so?
well, say carbon capture and sequestration, for example, it's currently very difficult to, at least in the United States, to get the permits to drill a Class 6 well for CO2 sequestration. So we have technology that will let you capture the CO2. But if you can't drill a well, then you've got to build a very, very extensive pipeline network. And to build a pipeline network, you've got to cross a whole lot of people's land, and you've got all kinds of issues with that, and all kinds of legitimate needs that people have for doing environmental studies and all the rest of it, which just makes it a much longer, slower, and more expensive process than it needs to. And the answer there is probably that we need to look at how we get wells permitted and make sure that we make it as easy as we can so that people don't have to build millions and millions of miles of pipeline to be able to do carbon capture. And we will need carbon capture, not just for heavy industry. We'll need it for some part of our electric power generation, because it's very hard to run a grid completely on wind and solar. You need to have some dispatchable power, because you're going to have times in the winter when there's not much sunshine and the wind's not blowing, and you still need electric power. And you can't build enough batteries to cover an entire winter's worth of electricity. That would be horribly expensive and also very bad from a carbon footprint standpoint. So I think there are policy things that could be done to accelerate progress towards being carbon neutrality or net zero, whichever way you choose to look at it. But it's not a lack of investment. There's no lack of investment in things that have payback. And at least from the standpoint of industry. Now, there is maybe in some sectors like the building sector, there's a lot more could be done in building efficiency.
Sure.
And there people don't necessarily have the funding. And it can be complicated in buildings, because if you're a retail operator, you may be leasing your space from a holding company which manages the space, but they don't actually own the capital asset of the building. And so there's all these questions about, okay, well, who would invest in making that building more energy efficient? And you get into a lot of well, it depends, and then it's harder to take action, right?
Well, let me ask this. What were the key technology changes that you made at Honeywell that allowed you to reduce the carbon intensity of the company overall by a pretty significant amount over the course of the past 6 years?
Yeah, well, in fact, actually, it's even more significant, because we started our journey to net zero in 2004, and we'd already actually reduced our carbon footprint 90% by 2018.
Okay.
So we went from 20 down to 2, and then we've been going down from our 2018. We re-baselined in 2018 because we were getting into the point where we were talking in single digits, and so we said, okay, let's start again from 2018 basis. So we did a lot of things around our sites, and we one of the things that's an advantage we have in Honeywell, we're a controls automation company. So we do systems that measure things and then control things and actuate things. The easy example that people think of is the thermostat, which is where Honeywell started out. That's a single measurement. You measure a temperature, and it's a single manipulated variable. You then control the heater originally, right? And then later it became you control the heater and the air conditioner. But obviously we extrapolate that out to very, very complex systems now, like much bigger buildings, whole campuses, chemical plants, aircraft, things like that. So when we looked at our own footprint, we have industrial plants, we have offices, we have facilities that we use for service and things, and we went through with a whole portfolio of all the things that we could do to make those sites more energy efficient. So simple things like switching, we moved away, all of our lighting moved to LED lighting. Deploying variable frequency drives, looking at the efficiency of the equipment that's installed, upgrading the air conditioning and HVAC systems, and then smarter things around scheduling and zone control, right? So turn the lights off and turn the air conditioning down if people aren't using a particular zone of a building. And we deploy these same technologies for our customers. We've actually run over 3,400 projects where we have guaranteed energy cost savings. We've guaranteed, I think it's about $9.2 billion in energy savings for our customers, government sites, hospitals, schools, fire departments, all around, mostly in the US, but all around the world. And we know that these technologies deliver value. So we can look at the age of a building and we can say, yeah, for this kind of building, yeah, what's your energy bill? Okay, we can guarantee you whatever, 10, 20%. Based on the age of the building and the kind of facility. So we have very high confidence in those kinds of technologies. That's been a big part of it. The industrial footprint, obviously, it's some of the other things. So looking at more efficient heating, and then looking at things like these fugitive emissions. The technology that we use to find methane, actually, we use it to look for our own F-gases.
Right.
So in our manufacturing plants that manufacture refrigerants, some of those refrigerant molecules, some of the raw materials, some of the intermediates are very high global warming potential. So if they have a global warming potential, they also have an infrared fingerprint, and that means we can detect those leaks and mitigate them using our same leak detection technology we use for methane.
Well, and I think that's an important point, that there are these adjacent applications for emerging technologies that once you've solved it in one domain can be applied in a variety of others to potentially not just lower the emissions, but to increase profitability.
Exactly, yeah. And better process control, better process automation always saves energy, right? And better building management and better scheduling of how you handle your HVAC. And like if the building's not occupied on the weekend, don't leave the HVAC running with the temperature set to 65 degrees.
Right.
Simple stuff like that can actually make substantial savings in your operating costs. So the stuff that we've done for Honeywell, it's actually all come with cost savings.
In terms of your 2035 goal to be carbon neutral, tell us about how you define carbon neutrality and what's the mix of reduction and carbon capture and sequestration that gets you to a net zero state?
Yeah. So our goal is to be carbon neutral from our operations by 2035. So what that means when you go and check the fine print is we're going to have no greenhouse gas emissions from our scope 1 and scope 2. Okay, it doesn't include the whole of our supply chain and scope 3. That's in our SBTI goals for 2037, where we start bringing scope 3 into it. So in terms of our own operations, obviously we have fleet operations. We have aircraft that we fly. We have people who we put on commercial aircraft. We have a lot of trucks and things that drive out to do services. We have our own manufacturing. We have most of our carbon footprints actually in our manufacturing plants, particularly for our chemicals businesses.
Yeah, I would imagine so.
And then we have our sales offices and everything else. So we have obviously been tracking all of this for a long time, actually well before 2018. Back in the early 2000s, we started tracking all of this and getting an idea of what our carbon footprint was. So we know our sites. For most of our sites, vast majority of our sites, in fact, are electric only. Because we're a global company, we have a lot of our footprint is in regions where you don't need much heating. So for those, we have plans to move our electricity over to being fully renewable. And we're doing some of that with on-site. We have a lot of our sites where we now generate our own solar power, and we have our own batteries. We manufacture battery systems. So we have been running microgrids for our customers for many, many years, right? If you're a process controls company and you're providing control systems to an oil refinery, every oil refinery essentially has its own electric grid. Yeah. Because they generate their own electricity. They have multiple turbines, and they also use they have backup grid power, but they do a substantial amount of generation. So all of our control systems have always been able to handle that and to operate a microgrid. Well, now we're deploying that same controls technology to tie in renewable assets like solar panels, wind turbines in some cases, backup generators that are fueled with renewable diesel. Same sort of thing as the sustainable aviation fuel, and then tie those generation assets together with the building, and then manage the building loads by doing load shedding as necessary, so as to optimize the use of the renewable power and the batteries, and minimize the use of high carbon intensity power. Particularly, what that means is particularly avoid using grid power during peak hours, like 6 to 10 p.m., because that's when the grid power has the highest carbon footprint. So we're managing our scope 2 very closely to basically get to net zero. Some countries will get there for us. I mean, Brazil's already pretty close to net zero. Brazil's grid is now, I think, over 90% decarbonized. But in most of the world, they're not going to be at net zero by 2035 on their electric grid. And so we'll have our own power through our own local grid to make sure that our scope 2 has gone to zero. Scope 2, that's electrification. Now, for the scope 1, obviously for fleet operations and things, where we can, we will electrify. For aviation, where we can, we'll switch to using sustainable aviation fuel made with our own technology. But there's a part of our scope 1 emissions, which is from burning fuels in high temperature processing. A lot of that is in our chemical plants. And for that, we're going to have to do things that are that get to that difficult to decarbonize part of the scope 1 footprint. So we're going to either do carbon capture, or we're going to switch to burning hydrogen, where the hydrogen has been generated as low carbon hydrogen. So that may be green hydrogen if it's available. If it's not available by 2035, that'll be blue hydrogen with carbon capture. So for those chemical plants, we're looking at both options. Some of them we're going to source with hydrogen, and we'll just keep running the existing burners, but we'll run them all on hydrogen. And one of our businesses actually makes hydrogen burners. So we know we can burn hydrogen with lower emissions, not just CO2 emissions, but also lower NOx emissions compared to burning natural gas. And then for some of the sites, we're gonna put in carbon capture systems, and what we'll do is we'll generate the heat for the site in a central facility with carbon capture. And again, it's going to come down to where is it easy to do that, right? Where's there a CO2 pipeline or a local Class 6 permitted well that allows us to do the CCS?
So as you think about the infrastructure that you operate, it's essentially a lot of increasingly closed, nested loops of energy and carbon capture cycles that you will be combining in various ways to address the local situation and in the aggregate lower the overall footprint. But again, I still haven't got a solid sense of how much of that net zero will ultimately be the result of carbon capture. Do you have it? Do you think you're going to still be offsetting 20% of the total operational energy?
Oh, okay. So when you say offsetting, okay. So let me answer that as a different question. Our plan is not to use any offsets at all.
Okay, that's great to hear.
Right. So we plan to do carbon capture. Don't get me wrong. We're going to capture our own carbon. But
you wouldn't need an offset then. You've captured it.
That's not an offset at all. That's actually capturing the carbon.
Right.
If you ask where do we plan to go out and purchase carbon offsets in like the voluntary carbon market, our plan is to not do that. Our plan is to, as much as we can, mitigate our own emissions by capturing our own CO2. Now, there will always be a part of our CO2 footprint that we can't mitigate. Right. So even when you burn sustainable aviation fuel, unless you have the feedstocks picked very carefully, it's not completely carbon neutral. It still has some level of carbon footprint. So there'll always be some amount of flight operations that can't be captured. There may be some sites where we can't get a permit for a Class 6 well, and it's too hard for us to get hydrogen. So in the end, there will be a residual part. At the moment, when we add up all of our projects, we have 90% of our carbon footprint already covered by a project that is planned. So the remaining 10%, we haven't yet developed the project, but we've actually got, we know what project. It may not be that we're going to execute it this year or next year, but we know the project that we're going to use for 90% of the carbon footprint. The final 10, we will probably find projects to cover at least a part of that. There may be some residual amount, 5%, 3%, whatever it turns out to be, where we'll say, okay, for this, we really do not have a way of actually capturing the CO2 ourselves. And for that, what we would do, we are not going to go out and buy offsets. What we would do there is we would actually put in direct air capture, and we would then, using our own technology again, we would put in a system that would actually capture an amount of CO2 equivalent to that. So we would have technology where we could guarantee that we were picking up the CO2, that it was fully additional in the environmentalist sense, right? That it's not something that would have happened otherwise, and that we're then able to meter the amount of CO2 into a storage site. And we would run that somewhere where we're already doing a CCS project, so where we've already got the well or the ability to actually sequester the carbon.
That is really impressive scope 1 and 2 progress. I want to dig further into how you're thinking about scope 3 in a moment, but we need to take a quick commercial break. We'll be right back. Now let's get back to the conversation with Honeywell's Chief Sustainability Officer and Chief Scientist for Sustainability, Dr. Gavin Towler. Now, Gavin, we've talked a lot about Scope 1 and 2 emissions. And again, congratulations on not just the impressive progress, but the plan to get to net zero that you described. But you also mentioned that Scope 3 is a unique challenge, and it is for many companies. What's Honeywell's approach to managing and reducing its Scope 3 emissions? And how are you bringing your supply chain partners into that project in such a way that you can coordinate your efforts?
Yeah, Scope 3 is a different challenge because obviously Scope 1 and 2 you control yourself and you have a lot of influence on the policy that's deployed. Scope 3 is all about influence, and there's really two parts to Scope 3. There's the upstream part, which is where do you source from, and what's the carbon footprint of your suppliers, and to what extent can you influence them to reduce their carbon footprint, so reduce their own Scope 1 and 2, or reduce the carbon intensity of the materials that they're using to make things for you. And then there's the downstream, which is what are the full life cycle emissions of the products that you sell. And obviously, as an industrial company, Honeywell makes things that get used. Right, so we're not just producing something that's like one and done. I mean, we make stuff that our customers buy that they then put into service and run for 30 years. So our business actually depends on selling things that are going to continue consuming electricity for a 20 or 30-year life. So we're not going to make that go away because we can't say, okay, well, it's going to stop selling products. That would not solve the world's problems. That would just mean we go out of business and instead people buy the equivalent Chinese competitor or wherever else in the world things are being made. So we have no intention of going out of business and walking away from actually making product. So we have to understand both of these things, the carbon footprint of our suppliers and the carbon footprint of things that we make. And when you actually look at that for Honeywell, some of the product categories that we have intrinsically have very, very high emissions when they're in use.
Sure.
We make aircraft engines. We make burners. You know, I talked about the fact that we make burners for hydrogen. Well, we make burners that can be designed to run on natural gas or run on hydrogen. If you run that burner on natural gas, you're going to have a very high carbon footprint. If you run it on hydrogen, it's going to be zero. We sell that burner to somebody, and then they make the decision of what fuel they put into it, right? So we will, you know, we have to, in stating our emissions from that product in use, assume that they're using whatever the overall average mix is between methane and hydrogen. We can't tell them don't burn methane in the burner.
Right. Well,
so what steps are we taking through? Oh, sorry, go on.
No, please go ahead and finish your thought.
Yeah, so what steps are we taking to reduce our Scope 3? Obviously, we are, like most companies, we're working with our vendor network. We're working with them to say, okay, well, what things are you doing? And we obviously, as a supplier of technologies that can help reduce the Scope 3, we go to our vendors and we say, well, you should be thinking about deploying this, this, and this. These are things you can do that will bring your carbon footprint down. So that helps on the supply side. And so we're working with our procurement team all the way through our supply chain to make sure that we are taking full advantage. And we're also using it as a decision in our buying. We can actually, all other things being equal, we actually award points, if you like, for companies that are able to supply us with an equivalent piece of equipment or raw material, but at a lower carbon footprint than somebody else. On the emissions from our products in use, we are now, as part of our new product development, we always think through what's the carbon footprint. We look at the life cycle analysis. So we're looking to actually reduce the lifetime energy consumption of all of our products. Across most of the products that we have, they're electrical products. That's relatively easy. And then for the things like engines and burners, obviously we want to improve the efficiency of them. But most important, we're designing them to run on net zero fuels. You know, if we made aircraft engines, we want them all to be rated to run on sustainable aviation fuel. And increasingly also, we're developing in the aerospace area, we're developing new next generation propulsion technologies like electric aircraft, hybrid electric aircraft, and hydrogen-fueled aircraft that will be completely net zero in their operations throughout their service life.
There's a lot that we could dig into there, but let me ask about the downstream scope 3 impacts. Have you looked at how you could also recapture the materials from the products, even 30 years from now, in order to lower the overall lifetime footprint of those materials and essentially bring them back to your scope 1 and direct emissions?
Absolutely. And, one of the things we do, I said we have our own carbon capture technology. So for all the people who have bought burners from us in the past, and who are running those burners on methane, we absolutely know where they are. We absolutely know the size of their burners. We are, of course, reaching out to all of them and saying, if you want to keep running it on methane, you might want to consider putting carbon capture in. We're also reaching out to them and saying, if you are running on methane and you want to think about switching over to hydrogen, we can change out the burner that you bought from us 10 years ago for a burner that is now hydrogen ready. And then you'll be able to run on 100% hydrogen in the future. So we have an ongoing conversation with all the customers who bought our burner technology around what are your options for continuing to use burners, but moving them to either be on a net zero fuel or on a CO2 mitigated system. And in a lot of these applications where people use burners, you can't electrify very easily. It would be extremely difficult because of the kinds of temperatures that you're at.
Yeah, we're not talking about gas stoves here. We're talking about something else entirely. We don't have an induction solution for that.
Yeah.
Let me ask you about hydrogen. It sounds like you think hydrogen is a viable alternative to gasoline and diesel. Do you see that as the primary use of hydrogen, or is it mostly an industrial fuel?
Primary is going to be hard to get to. My view, or our view from Honeywell, we don't see hydrogen having a big impact in displacing gasoline.
Okay.
So we think the gasoline is going to go away, but it's going to be because people will increasingly drive hybrid electric vehicles or fully battery electric vehicles. And that, I think that trend is now fairly well established. It may take longer to transition than people expect, because we've just sort of we're at that point where the growth is just starting to really get beyond the early adopters and into the mass market. But we think that the light duty vehicle sector probably ends up being largely electric. Heavy duty vehicles, we do think will end up being a substantial amount from hydrogen. There may be some new breakthroughs, some new drivetrains or new clever ways of deploying batteries, but heavy duty vehicles are capital assets, and the amount of time that they spend in service really matters. And if you look at like truck driver schedules and, for Class 8 trucks, you can kind of get an idea of what usage the fleet operators are looking for. That doesn't leave the time that's needed to charge the amount of batteries that are needed. Yeah. So without some sort of change in how you fuel those vehicles, we think that they're likely to end up on hydrogen engines. Heavy industry, industry is a huge amount of global CO2 emissions. Some of it is going to electrify. And we think that of all of the heat being used in industry, about half of it can probably be supplied by electrification, particularly with heat pumps. Heat pumps are a great technology that's not been widely used yet, but heat pump allows you to boost the temperature of available heat. So you can take waste heat and you can boost its temperature up to the point where you could use it for low-grade heating things. And that's going to meet quite a lot of the needs of industry. But about half of the heat that's needed in industry is going to either come from fossil fuels with carbon capture or from hydrogen.
So what do you imagine the challenges are in transitioning our current fuel distribution system to provide hydrogen at scale? Do we have to build new pipelines? Will we be able to repurpose existing pipelines? Or is there an alternative way to move the hydrogen from place to place?
Well, what a lot of people don't know is that there's actually extensive experience running hydrogen pipelines. So there's a whole pipeline grid network in the US Gulf Coast area. There's another whole hydrogen pipeline grid network in the Netherlands Rhineland area, where people already have been generating hydrogen. Multiple different companies put hydrogen into the grid network. They supply it to refineries, petrochemical plants all across the Houston kind of area. We do the metering for that. We provide metering systems. You can measure hydrogen. All of those systems have operated safely for many, many years. People were actually supplying pipeline hydrogen to oil refineries 30 years ago when I was starting out my career. So that is a good example of a known technology. Now, the kilometers of hydrogen pipeline available are much less than the kilometers of natural gas pipeline. And you do need to have the safety standards be there for hydrogen. It's not exactly the same. You will need some upgrades, but it's very doable. How willing people are to change out their natural gas system to a hydrogen system? Obviously, for people's homes, there's a level of concern around, well, is this equally safe? Is this equally safe to the black pipe system that I had before? But for manufacturing plants, they already have hydrogen systems. A lot of refining and petrochemical plants already actually use hydrogen in their fuel gas. So it's not there's not an acceptance issue because they already know how to do this. It's really just a question of increasing the amount of supply and then backing out methane. So for a lot of the industrial applications where we're talking about switching to hydrogen as a fuel, this is not a radical, well, someone's going to have to do this centrally, they're going to have to lay a new pipeline. No, you're going to have to adjust the existing hydrogen plant you have to produce more and then back more methane out of your fuel. And that's basically what we're doing with ExxonMobil at their Baytown refinery. So we have an announcement about that we're going to be building one of the world's largest blue hydrogen plants. It's actually going to capture 7 million tons a year of CO2. And it's going to provide about a third of Exxon's energy requirement for Baytown.
As you look ahead, what emerging technologies or innovations within Honeywell that you're investing in do you believe are going to have a significant impact on our ability to be a sustainable economy? What should people be watching for from Honeywell?
I would say, we've touched on some of these things already. Sustainable aviation fuel is one. It's not coming direct from Honeywell, but we're supplying the technology to everybody who's making it. Methane emissions. We really do need to get a handle on all of the methane that's being emitted, and our sensing technologies are going to enable customers in the oil and gas industry to go after that. Great payback on that one. Hydrogen and carbon capture, and it really is it's sort of an either or. Either you continue using fossil fuels and capture the CO2, or you switch to hydrogen. But that's going to be key for heavy industry and also for dispatchable electric power. Microgrid technologies, so deployment of battery systems as an enabler to going to higher levels of renewables and giving you that ability to have the grid resilience and also to operate facilities in island mode if the grid goes down. And then, of course, digitization and automation really cuts across everything, because any industrial operation or any commercial operation, you want to optimize it first before you start trying to reduce the energy.
No, even in the home, using a thermostat.
Exactly, because you otherwise you set yourself a bigger target than you need to.
Gavin, thank you so much for spending time with us today. How can folks follow along with what you're working on?
Yeah, if you're interested in finding out more or seeing things that Honeywell is doing, obviously we have our website, which has a lot of information about our sustainability products. And this year we have an ESG report we put out every year. This year we actually put a new section into the ESG report where we talked about some of our product offerings and what we do for our customers, as well as our own carbon footprint. And I would say the other place to look is probably LinkedIn. We do have a lot of posts. We have a Honeywell LinkedIn site, and we post a lot of our sustainability materials there because it's something that we're very proud of what we do here, and a lot of our employees are very passionate about developing these better solutions because they want to see technology contributing to solving society's challenges.
Well, Gavin, thanks very much for spending time, and we look forward to keeping in touch and following Honeywell's progress.
Great. Thank you, Mitch.
That was my conversation with Dr. Gavin Towler. He is Chief Sustainability Officer at Honeywell. The company's ESG report does provide a wealth of interesting examples of technologies that can reduce emissions from industrial processes, which contribute to eventually reducing our individual impact through more efficient consumption. And you can find the report and much more at honeywell.com. Industrial emissions associated with making the energy and things that we consume, as well as moving those goods to market, produces the vast majority of CO2 that warms the planet. According to the International Energy Agency, those emissions continue to grow, but more slowly, and it is predicted they will peak during the mid-2020s. That is, just in the next few years. After that, the challenge is to reduce cumulative emissions as fast as possible. Gavin explained how Honeywell is looking within its production systems, not just for reductions, but also how to capture and use wasted energy, such as heat generated by production processes, for other purposes. In other words, you don't have to burn more fuel to create more energy. You use the waste energy that you've already got. It's encouraging to hear an industrial giant like Honeywell commit to net zero without resorting to carbon offsets, because it provides greater accountability and confirmable additionality. That's the assurance that the CO2 is captured and not counted twice. That's something that many carbon credit systems have been unable to deliver, and there's a lot of controversy swirling around them these days as a result. It would be good to see hydrogen in electric airplanes, as aviation is one of the industries with the most stubborn carbon footprint. But we also heard that that transition will take time. During the decade or decades that transition is going to require, we need to look for every opportunity to squeeze emissions out of our systems, even at home, such as by avoiding electricity use and heating or cooling during peak demand hours, when utilities switch on highly polluting peaker plants that run on natural gas. Those lessons need to be shared as widely as possible, not just from Honeywell, but from all of us, and we'll continue to offer those tips on Earth 911. So stay tuned. I hope you'll also take a moment to share this podcast or any of the more than 450 interviews that we produced on sustainability in your ear. Folks, when you write a review on your favorite podcast platform, it helps your neighbors find us. You are the amplifier that can spread more ideas to create less waste. So please tell your friends, family, coworkers, the people you meet on the street that can find sustainability in your ear on Apple Podcasts, Spotify, iHeartRadio, Audible, or whatever purveyor of podcast goodness they prefer. Thank you for your support. I'm Mitch Ratcliffe. This is Sustainability in Your Ear, and we will be back with another innovator interview soon. In the meantime, folks, take care of yourself, take care of one another, and let's all take care of this beautiful planet of ours. Have a green day.